Thank you very much introduction. So my name is Yosuke Todo from NTT Secure Platform Laboratories. So today's talk is bit-based division property and application to Simon family. And this work is joint work with Masakatsu Mori in Kobe University. So first of all, I talk about the overview of my talk. So division property was proposed in Eurocrypt 2050, and this technique is a new method to find good integral characteristics. So when we use the division property, we evaluate the propagation characteristics on various representations of the division property. So for example, now when the target cipher is SPN with m and bit S boxes, we use the division property dk n to the m. And if the target is phaser cipher with n-bit f function, we use division property dk n to the 2. But division property is very powerful for S-box-based cipher, but if the target cipher is non-S-box-based cipher, division property can't find good integral characteristic previously. So for example, as the target cipher is Simon, so Simon does not consist of S-box, so we can find a good integral characteristic. So now we focus on the integral characteristics on Simon 32. So in Eurocrypt 2040, so 50 rounds was found, but this integral characteristic was found experimentally. So this means this is possibly doesn't work for all secret keys. And Eurocrypt 2050, this paper is a proposal paper of the division property. So by using this technique, I find a 10-round integral characteristic. But this technique, f function is regarded, Simon's f function is regarded as any function of degree 2. So very recently, ICISC 2050, so Chan et al. Proposed shows that the existence of 30th round integral characteristic by exploiting algebraic degree. So now this work, so I theoretically proved the existence of 50th round integral characteristic by using bit-based division property. So as a result, one's characteristic, this experimental characteristic, theoretically is proved. So this is the outline of my talk. So first, as a background, I talk what is integral cryptanalysis and division property. So this talk has 3 contributions. As the first one is conventional bit-based division property. By using this technique, we can prove the existence of 40-round integral characteristics. And second contribution is new variant of bit-based division property. So I call it bit-based division property using 3 subsets. So by using this technique, we can prove the existence of 50-round integral characteristic. And finally, the so-called probable security. So this means impossibility to find integral characteristic using the bit-based division property. So first, this is essence of integral cryptanalysis. So now I explain integral characteristic. So first, we have a chosen plain text set X. This is a subset of F2 to the N. And by applying block cipher ESK, we get the ciphertext set Y. And for all possible secret key, so if this equation is equal to 0, so we say ESK has integral characteristic. So by using this characteristic, we can execute integral cryptanalysis. So first, I find integral characteristic, but this characteristic doesn't cover all full round cipher. So only this characteristic only covers reduced round ciphers. And append some rounds and guess the round key last round function is used. In this case, in this example, so we guess RK prime and compute the set Y from ciphertext set Z. And if we guess correct RK prime, this equation is always 0. But if this equation is not equal to 0, so this means the guessed RK prime is incorrect. And by repeating this procedure, so we can recover the correct RK prime. So in the integral cryptanalysis, it is very important to find integral characteristic. And there are two classical methods to find integral characteristics. The first method is propagation of integral property, and another method is exploiting algebraic degree. The first method was proposed by Knudsen and Wagner in FSE 2002, and second method is so-called higher-order differential cryptanalysis. So division property is the third method to find integral characteristic, and this core idea is generalization of integral properties such that it can also exploit the algebraic degree. So this is a simple version of the division property. So now we have a merge set X, and whose element takes n-bit value. And now we want to evaluate the division property of this set. In this case, we choose U from the same set, and so evaluate the parity of bit product function. And U belongs to U0 or U question. So assuming X has the division property dkn, this means this parity is equal to unknown if the Hamming weight of U is greater than k, but otherwise the parity is 0. This is a more complicating version of the division property, so we say corrective division property. So in this case, the merge set X takes m-dimensional vectors whose element takes n-bit value. So the evaluating method is almost the same as a simple version of the division property. So we prepare vector U and divide U0 or U, and evaluate whether or not U belongs to U0 or U question. So this case, assuming that X has the division property dkn to the m, the parity is unknown if there are k such that the Hamming weight of U is greater than k, otherwise 0. So this is a very simple example. So now, division property is dk8 to the 2, and k is 15335160. This means if pick U, vector U, such that the Hamming weight of U is gray space, this gray space, the parity is unknown. Otherwise, the parity is 0. So it is very important to understand the behavior of redundant vectors. So for example, now k prime has 4, 5. So but 4, 5 is the 4, 5 is already unknown because of the 3, 3. So in this case, dk8 to the 2 is equivalent with dk prime 8 to the 2 because the subset, the parity is unknown, is unique. Okay, so from now, as a new content, so first one is conventional bit-based division property. So now I want to apply this technique to Simon. So, but Simon this is the round function of Simon, but the f function consists of rotation and XOR. But so this means we can't decompose the f function into subblocks like S box. So in Euroclid paper, this function is regarded as any nonlinear function with degree 2, and evaluating the propagation characteristic. Finally, in Euroclid paper, proves the existence of 10-round integral characteristic on Simon 32. But we already know more better integral characteristic. So for example, in Euroclid paper, so this integral characteristic was confirmed experimentally, but this characteristic covers 15 rounds. So, but this characteristic is confirmed by experimentally, so this is possibly doesn't work for all secret keys. And Very recently, so Chan proposed a 30-round integral characteristic by using degree estimation. So there are 2-round gap between the proof and the experiment. So my research motivation is to fill up this gap. So our first approach is actually very simple. So now, round function of Simon is like this. And previous application, so we regard this function as any nonlinear function with degree 2 because we can't decompose this function. But, so we can't decompose it like S-box, but we can decompose the round function of Simon every bit. Namely, previous division property, we use dk n2 to the 2. But in this case, we use dk 1 to the 2n. So, but since this is not against the definition of division property, so we can directly use the propagation characteristic of original division property. And so we call it the conventional bit-based division property. So now we apply this conventional bit-based division property to Simon 32. So we first prepare chosen plaintext such that the MSB is constant and the others 31 bits active. So namely, it uses 2 to the 31 chosen plaintext. So this division property is dk1 to the 32, where k is like this. So this is a propagation characteristic. So let's only, so please focus on this output of 30 round. So the number of so elements in k is 136 vectors, and this is such vector. So this means if we pick 1 bit from left half, the parity is unknown. So if we pick 2 bits and compute and calculate parity, the parity is unknown. This means if we only pick 1 bit from right half, the parity is balanced. So this means this integral property is the left half is unknown, but right half is balanced. So, but Simon is very specific structure. So round key is XORed after F function. So we can easily extend 1 round. So for example, now L is a CAAA, and R is active or actives. In this case, so we can prepare chosen plaintext like this. So we can easily extend 1 round without guessing RK. So by using this technique, we can prove the existence of 40th round characteristic. So next is a new variant. So unfortunately, I have a 1 round gap. So conventional bit-based division property find a 40-round integral characteristic, but there is 1 round gap between the proof and the experiment. So my next motivation is reason there is 1 round gap. So this reason is the conventional bit-based division property sometimes overlooks useful property. So this is a very simple example. So unfortunately, Simon 32 is very complicating structure. So we only pick 1 bit from right half and pick 3 bits from left half. And this is a cooperation of Simon structure. So 4-bit is the plaintext inputs, and y is output. And this is a round function. And assuming the input division property is like this, in this case, the output division property fulfills this structure. So additionally, we have 0, 0, 0, 1. This means the parity of f of x and 0, 0, 0, 1, it becomes like this. And this term is unknown because of the definition of this division property. But now, let's assume the parity of 1, 1, 0, 0 and 0, 0, 1, 0 is 1, not unknown. So in this case, conventional division property becomes this type input set also division property 1100 and 0010 because conventional division property doesn't distinguish the parity is 1 or unknown. So only its technique distinguishes the parity is 0 or unknown 0. So, but in this case, this term is cancelled by exclusive OR, so the parity becomes 0, not unknown. So this means we are also able to exploit vector U such that the parity is 1. So because it is possibility that the parity becomes 0 by cancelling. So this is a definition of bit-based division property using 3 subsets. So in this case, we use set K and set L. And set K is used to represent the unknown space. And L is used to represent the parity is 1 space. So unfortunately, the propagation characteristic is very, very complicated. So I only talk the essence. So now we have the set K and L, and Ki and Li is the input division property. So now this is a random function of Simon. So basically, we can evaluate the propagation of Ki and that of Li independently, like this. And this propagation is completely same as that of conventional division property. But this type is a little different from that of conventional bit-based division property. But this propagation characteristic is derived from the analysis of Boolean function. So, and by XORing secret round key like this, so a new vector which is computed from L is inserted into Ki plus 1. So by using this technique, so we evaluate the propagation characteristic of the target Simon 32. And now we first prepare chosen plain text set. The MSB is constant and other bits are active. This division property is like this. So after 40 rounds, we get this division property. So it's very complicated. So by representing integral property, so in this case, this means this integral property. So we get 50-round integral characteristic by using 1-round extension technique. And balanced bits, the number of balanced bits only 3, but so experimental integral characteristic also has this balanced bits. So the proved characteristic is completely same as experimental characteristic, including the position of balanced bits. So finally, I talk about so-called provable security, but it's so impossibility to find integral characteristic using the bit-based division property. So the previous 2 contributions, so the application is only Simon 32. So this is because it is practically impossible, infeasible to evaluate the propagation bit-based division property for block cipher. So this means when the target is n-bit block cipher, it roughly requires 2 to the n time and memory complexity. So for Simon 32, this time and memory complexity is upper bounded by 2 to the 32. So it is feasible. But for example, Simon Y 128. So this is infeasible. But I want to propose any suggestion for other Simon family. So why I propose 2 approximating methods. So one is approximation for attackers. This means the found characteristic works for all keys, but if the accurate propagation executes, so we can find more better characteristics. So another approximating is for approximation for designers. So this means if we can get integral nothing by using this approximation, so the accurate propagation also integral nothing. So this is essence of this technique. So now this is the accurate division property. And now 1, 5, 3, 3, 5, 1, 6, 0. So the number of vector k is 4. So now we want to reduce this the number of managed vector. So the first method is approximations for attackers. In this case, so we insert 3, 1, and this case 3, 3 and 5, 1 can be removed because this 2 vector is redundant. So in this case, so the unknown space expands, so previous now. So the found integral characteristic is worse than or equal to the integral characteristic by accurate propagation. And by using this method, we get integral characteristic for attackers. Another approximation is approximating method for designer. In this case, we remove 1, 5, and 6, 0 is very simply. And in this case, the unknown space is reduced. So the found integral characteristic is better than or equal to the integral characteristic by accurate propagation. So I applied this technique to Simon family. So unfortunately, so approximation for attackers, we can't improve from results in very recently. So I only, as the meaning is only approximation for designers. In this case, so we evaluate the accurate propagation characteristic of the division property up to 6 rounds. From 7 rounds, all vectors in L are removed, and K, whose Hamming weight is high, removed. Only K, whose Hamming weight is small. By using vector K, whose Hamming weight is small, is used. So this is the result. So accurate division property can find R-round integral characteristic where R takes a value within the above range. So in Simon 32, so we can perfectly evaluate the accurate propagation characteristic. So this means 50 rounds. So this is a tight. And Simon 128, so we can get a 25-round integral characteristic. But if we can evaluate accurate propagation characteristic, the number of covered rounds is limited to 28. So, but this is only provable security for integral cryptanalysis using division property. But I think Simon division property can find accurate integral characteristic on Simon 32. So I expect that the other also find accurate ones, but it is no evidence. So, but then the right number becomes provable security. Okay, so finally I conclude my talk. So I propose a bit-based division property, and this simple version covers 14 rounds, and bit-based division property using 3 subsets. So by using this method, we can prove the tight integral characteristic. And by using approximating methods, so we can prove provable security against the integral cryptanalysis using division property. But open question is, how do we evaluate the accurate propagation against all Simon family on feasible environment? So currently only Simon 32 was evaluated, but other Simon family is I can't evaluate the accurate propagation characteristic. So thank you very much.
Thank you.